So let's start bringing it back all together here. We've done some natural climate change. We've now thought about some kind of current climate change and human impact. We want to bring it all together. So this is our third page of today's assignment. Hopefully you kind of look through it and have a little bit going already. I just want to make sure you've got all the details. So as we're going through, if there's something you need to add, please do that. So you have the most current information and accurate information as we move forward and get ready for our quiz on Wednesday. So first question up here, has the Earth's climate changed over time? Hopefully everybody's eyeballs went right over here. Yes, we know that we've seen different patterns of change both within the past and then also kind of a new pattern forming right now, and likely into the future we'll continue to see things change over time on a global scale. So when we look at those patterns, we really can break it down into two sections. We've got a past climate, so that was our 800,000 years of data, our past climate pattern, and then we also have a kind of current climate pattern happening right now over the last 100 years. So over here we're going to talk about what we've seen about climate in the past and what we're really noticing about climate currently right now. So when we talk about 800,000 years of climate data, that number should kind of stand out to you and help you remember that graph we looked at for both temperature and CO2 data. It was the graph where we saw CO2 in the air really fluctuating over time, but doing a consistent fluctuation, right? Rising and falling, not necessarily over specific times, but just a general increase, decrease of that data. And we saw the same thing with temperature, right? Whenever CO2 had a rise, temperature followed, and so on with a decline or a decrease. So that graph should pop into your head when we talk about past climate change. So a picture of that graph there would be great. Something about a consistent fluctuation or up and down pattern over time is what we want to know. What did that pattern look like? So we're just describing the graph. Over here, the main climate pattern in the last 100 years, we've noticed in the last 100 years, again, thinking about that graph, it's really steadily started to increase. We've seen a steady increase in CO2 over time, and it's important to just remind ourselves that it's gotten higher than we've seen in the past before. So it would be like if we go back to this initial graph, it kind of going, maybe that's a little high, but going off the charts, right? Higher than the highest highs we've seen in the past. So currently we're seeing a steady increase over those 100 years. Now, we've talked a little bit about a reason for each of these patterns or change. This first one, natural climate change, our main thought over here was those M cycles or the solar cycles, right? Those changes in the Earth and Sun relationship. So that was our, just for reminders, our tilt angle change, our orbit change, and our tilt direction. Right? Those are natural things that's happened that have then caused an impact to the Earth's climate. So the main thing we saw change there when we went through those summary questions was we noticed a change to the location of solar energy and direct rays. Right? Different parts of the globe getting more or less sun than they typically got. And that really had a change in seasonal variation. Right? That was the main thing we looked at. Did we have a more consistent seasonal change, or did we have a really varied seasonal change? So these M cycles were our reason for seeing that pattern, and that pattern really was driven by these climate changes. All right, when we think about the current climate pattern, this is where the carbon cycle really comes in. Okay, we're not so much noticing that this change is a natural change, but it's more of a human impact change, right? We're seeing a lot more use of fossil fuels, right? A lot more transportation, a lot more technology, or I guess not technology necessarily, but electricity use, more combustion, right? Our big carbon cycle word. Burning of fossil fuels. And what that's doing is, of course, putting more CO2 in the air. So the more we're using those fossil fuels, the more CO2 goes in the air. That's what's impacting our graph up here, right? That steady increase in both CO2 and then temperature is really starting to follow. So when we think about the main impact of more combustion, that should be the first thing that pops into your head. More heat is staying in the atmosphere. So a temperature increase. Right? Just like the graph tells us, more CO2, more or a greater temperature. Okay, we just finished that article, so we're seeing that temperature increase is having an impact on many things. The article really focused on sea ice and those walrus, and those sea ice are starting to melt. That, of course, is causing a rising sea level. There's a lot of other factors like more extreme storms, change in weather patterns, change in wind patterns, lots of impacts down the road that we're seeing this global warming have. We could even put albedo in here, right? It's changing the Earth's albedo. So here's what I want you to think of. I'm going to leave you off right here. Because we're thinking about all this human impact up here, creating this current pattern that we're seeing, we know that renewable energy forms can have an impact on that human piece. So just jot a couple things down here. Conclusion, how are renewable forms of energy, thinking back to try one, bringing it all together, how are renewable forms of energy supposed to slow that current rate of climate change? Think about what would their impact be and why. Why is that important? Okay. So you should have your flow chart now complete. You can get this whole thing submitted into Schoology. Use this to add a few things, maybe in this area, to your learning targets as we get ready for our carbon cycle quiz happening on Wednesday.